Hi everyone, and welcome to our walkthrough through the pre-processing module. Let's get started. All right, so before we start working with our algorithms, we need to be sure that the data that we're using are in the correct format. In order to do that, we need to build a clean data set, but we also need to build an economical data set. We need to build an economical data set because processing data is expensive. So we want to be sure that we pick only those attributes and only those rows as well that really are worth it and that will give us the most optimal result possible. So that's the first thing we're going to talk about when we talk about data pre-processing. Pre-processing means before we, in fact, apply any of our algorithms. And secondly, we will find out later on in this course that some algorithms take only numeric attributes, some algorithms and some of the math that we're about to do later will take only categorical attributes. So we need to be able to transform data from one format to another. That's what we're going to learn as well. And the whole idea is that we reduce our big data sets to a workable format. Because if you process too much data on any computer, it doesn't matter whether that's a server, whether that is a cluster, or whether that is your laptop, guess what happens? Your machine will start smoking. And you're learning here from my experience because I have actually broken a computer by processing too much data at one time. All right, so let's get started. When we start, typically we want to import our libraries first, and then we want to read in our data, and then we want to verify that we can see the data, and we do this with just the head command. You can also do this with the tail command, depending on what you want to see of the data set, whether you want to see the beginning or the end. And here's our data set. Here we're seeing the first 5 rows. Remember that in Python, the first row does not start with the index number of 1. It starts with index number 0. Okay, so let's get started with subsetting and aggregating data. Now, the idea is to reduce the data set with which you're working to the smallest possible size and include only the attributes and the rows that are useful and meaningful. This means when we have to edit our data set. So when we reduce the number of attributes or the number of rows, really what we're doing is we're subsetting. And when we summarize rows based on a common attribute, like all married people or all people under 17 or all people who have the native country as USA, that is called aggregation. And all these together really are called dimensionality reduction because we are reducing the dimensions. And remember, dimension is another word for attribute or feature in a data set. So let's get started with slicing and subsetting. Let's talk about slicing first. Slicing gets its magic from the iloc operator. The iloc operator literally means index location, which means the exact location of a data point within the data frame. Let's take a look at the syntax first, and then let's run through the adult data set and look at some examples. So the syntax is as follows. You start with the name of the data frame. Here it's just a generic data frame df dot, and then iloc index location. And then you have these angular brackets here. For the angular brackets, the sequence is within the angular brackets, before the comma, you have the rows, and after the comma, you have the columns. So 0 through 5, comma, and then nothing, shows you the rows. You have the colon, comma, 0 through 5, that shows you the first 5 columns. Here you're seeing all the columns, but the first 5 rows. Here you're seeing all the rows, but the first 5 columns. If you want to display only the first 5 columns and the first 5 rows, then you start with the first 5 rows here, comma, and the first 5 columns. Here's what this looks like. if we use the adult data frame here and we say, give me the index location for rows 0 through 5 and all columns, then we're seeing here index is 0, 1, 2, 3, 4. It's the first 5, right? But the index starts with 0. We're getting all of the attributes. Now we're going to turn this around. We're saying, well, give me all of the rows here, but give me only the first 5 columns. Okay, you see, we get all the rows, but we get only the first 5 columns. If we want to now constrain our display, or what we are looking at, to the first 5 rows and the first 5 columns, then we're going to have to define them on both sides of the comma here within these angular brackets. And then it looks like this. Okay, so here's the first exercise for you to build an adult short data frame. Subsetting does not require knowing the index number. We are not working with iloc when we subset. Instead, we work with the attributes, and we're basically building a filter for the attributes. Here's how this works. So if I want to find all the people who are 90 years old, then I will look at my age attribute inside of my adult data set, this one here, right? And I will say, well, from the data frame here, within this data frame, I have the age attribute. Please note this is in single quotes here and in brackets. I want to pull up only the people whose age is the same as 90. Now, this is not a mathematical operator here, the equal sign. This really is the same as. So let's do that. And what we're seeing here is we're pulling out all of the rows we're filtering out all of the rows of the people who are 90 years old. So what if we want to find the people who are younger than or equal to 20? We would use less or equal to 20. Go ahead and build the filter right here. And then follow up with a filter for all the people who are older than 75. That shows you how to use numbers for subsetting. Now, if you want to use subsetting with strings, then these strings need to be in quotes here, right there, because our education attribute obviously is categorical because we're not seeing any numbers here. But the principle is the same. And here we are saying, give me all the rows in which education is the same as bachelor's. So that's what we're seeing right here. And for this, string search, now find all the people in the United States and all the people from Cuba, please, using the same principle as the string search here, the string subsetting. So why is this important? This is important because, remember, our goal is to have a data set that is optimized for us to work with, right? So we want to make sure that the data set is manageable for the hardware, that it's not too big so that the server goes up in flames, right? But we also want to be sure that the data set that we're working with is practical for us to work with. Let's say you have 1,000 attributes and only 5 of those are really useful and meaningful and the other 995 are not, then there really is no benefit to working with the 1,000 attributes, right? So it takes a lot of discernment and critical thinking and some math that we're going to learn later in order to knowledgeably reduce the data set to a point where both our hardware and we ourselves are comfortable with the processing and the outputs later on. So I'll show you how to build your reduced data set now. There's 2 ways that you can do this. One is with subsetting, one is with slicing. We'll look at both. And the first one here is with subsetting. I'm using the adult data set here, and then I want to build a data frame just with age, education, and sex. And note here we have two sets of angular brackets. This is what it gives me here: age, education, and sex. And then, of course, all of the rows, but just the 3 columns. Now, of course, I do want to use this for further analysis, so I actually have to put the result of this filter, of this query, if you will, into an attribute or into its own little data frame. And I'm going to call this reduced data. So my reduced data frame is going to be the output of this filtering string, or this search string, or query, whatever you want to call it, right? This is the same thing. So if I do that, you will see there's no output, but when I display my reduced data frame, then that's what you're seeing. All right, I could also use iloc, of course, to build a smaller data frame. And for that, I can specify not just the rows here, 0 through 5, my first 5 rows, but I can also specify the index number of the column here, column 0. Column 0 is, remember, the first column, right? Column 1, which is the second column, because Python always starts with 0. And then so on and so on. And this is what this looks like at this point here, right? 0 through 5, comma, and then here, note the brackets again, the columns that I have specified. I can, of course, also combine the row filters and the column filters. I can combine my subsetting and my slicing here when I make a data frame where I say, well, I'm going to first filter on education being bachelor's, and then I'm going to, from this set that I have built, I'm going to display only the first 5 rows and these columns here. And that's what this looks like. So here we have started with subsetting, putting our subset into a data frame here. And then we have looked at using slicing to build a reduced data frame. And here we have combined both techniques. All right, now go ahead and build an adult small data frame with rows 70 through 80 and with all of the columns, because you're going to be needing that later. Remember how previously we talked about the fact that building a reduced data set for optimal processing requires a lot of discernment and critical thinking. That's especially true when it comes to aggregation and dimensionality reduction. Now, previously, we have learned the mechanics of making our data sets smaller. That is, how to select rows, how to select columns that we want to stick in a smaller data frame that we are going to use for processing later on. But really, we should be looking at the data themselves to show us ways in which the data can be summarized and simplified. And that can happen with either column-based aggregation. It can happen with row-based aggregation, and binning and bucketing and normalization. We'll talk about all of these. So let's talk about column-based dimensionality reduction first. So in our adult data set, we see that we have an attribute called marital status here, right? And we have an attribute called relationship. And, you know, never married, not in family, married, civilian spouse, that kind of looks like, almost like there would be a one-to-one relationship between these two attributes. And if there is, then we can maybe get rid of one of these, right? So let's take a look. The first thing we're going to want to do is to build a smaller data frame. I'm just going to call it household here, in which I look at just these 2 columns here, adult relationship and adult marital status. And remember, we have 2 sets of angular brackets here. So, and then I'm going to group my data by relationship to see how many marital statuses there are per relationship, and that will allow me to determine whether there is a one-to-one relationship between marital status and relationship. And what we're seeing is if there is a husband, the marital status could be married to a civilian spouse, married to a civilian. Oh, look at that. Okay, so it looks like there is a one-to-one relationship here between husband and married to a civilian spouse, maybe? Maybe, possibly. What about the relationship of not in family? Never married. Oh, divorced. Oh, married spouse absent. Well, that's different because here the marital statuses are different. For husband here, they look the same. Okay. Let's take a look at other relative. Married, civilian spouse. Oh, never married. Never married. Okay, but here still we have married civilian spouse. So not the same, not like here, right? Own child, never married, never married, never married. Okay, that looks like almost similar to the relationship and married civilian spouse, the husband here, one-to-one relationship. But when we look at unmarried, we see we have never married, we have divorced, separated, divorced, never married. So here we have various different levels again, and not just one, which is what we are seeing here, which is what we're seeing here. So we can say that we do not have, when we group by relationship, a one-to-one relationship between relationship and marital status. Now, if we group by marital status and turn this around, in other words, we're seeing the same thing, that this is not a one-to-one relationship because we're seeing different values here, various values in the relationship attribute that are associated with one attribute in marital status. So we have another one-to-many relationship. That's not going to help us eliminate the attribute marital status or the attribute relationship. We need both in the data set. So we've looked at the connection between relationship and marital status from all different sides, and we're still finding these one-to-many relationships that go both ways. So let's see if there's a better connection between education years and education. Maybe we can eliminate one of those attributes, right? Same process here. We're going to build a smaller data frame. I'm going to call this degree, that contains just our education years and our education. And then I'm going to group by, education years, just because I can. And I'm going to apply the lambda function again on education so that we're going to associate only the unique values for education with the corresponding education years. And then I'm going to display my data frame. All right, so here is what we're seeing for education years. We're seeing that we have a indeed one-to-one relationship here because there's only one value in my education level attribute here. So when education years are 7, I will know that it's always 11th grade. If education year is 16, I know it will always be doctorate. This is different from this arrangement here where we have a husband and 2 different values that are associated with it. So we have a one-to-many relationship here. Here is a clear one-to-one relationship. So what do we want to do here? We don't need both attributes, education years and education. It will be enough for us to have one of those. Now, the rule of thumb is that if you're eliminating an attribute from a data set, you will always pick the non-numeric values first. So in other words, for our data set, we're going to keep our education years here because numbers allow us to just do more things with them. We can do math with numbers. We cannot do math with categorical levels here. This is why we're going to eliminate our education categorical attribute. So how do we eliminate our education attribute? Well, there's different ways of doing that. The first way to do that is by building a smaller data frame in which we define exactly the columns that we want to store in that data frame, and we just don't store our education attribute in our adult4 data frame. We can decide to drop simply the education attribute from our data frame. For that, we use the pandas drop function, and here's what this looks like. Adult.drop, and then we have our parentheses here, and we say education, and then axis equals 1. Now, if the axis equals 1, that means we're dropping the columns. And then here we're seeing in our adult4 data frame, we're seeing age, work class, education years, marital status, everything except the education attribute. And the same drop function also comes in very, very handy if we want to remove specific rows from a data set. Now, if we specify rows, we have to set our axis to 0. In contrast to axis equals 1, axis equals 1 always applies to columns. Axis equals 0 always applies to rows. Very important. So here's how to use drop and or axis values in order to eliminate all the rows from our adult data set in which race is set to white. So I'm going to start by building my adult5 data frame, which is nothing but a backup of my adult data frame. And then so that we can find all the values of white for race, I'm going to set the index for this adult5 data frame to the values of my race attribute. Here's what this looks like. As you're seeing, instead of index numbers here, we now have our race as our index. This allows me to filter by the indices that are white and to exclude these from my data set. And that's exactly what I'm going to do here. Now I'm going to say, well, I'm going to use the drop operator, and the index here is white. And I'm going to use all the rows here because axis equals 0, remember? I'm going to delete all the rows with the label with the index of white. And that allows me here to see only Black and Asian Pacific Islander and so on, the other values, right? So that I have now eliminated from my adult data frame all the values that have white in the index here, and the index being race. Another way of applying the drop function to rows is by specifying the actual labels, the numeric labels for rows. So here, for example, I'm building a new adult5 data frame, and I'm using my adult data frame, and I'm just going to drop rows 0, 1, and 5, these index numbers. And I have to specify, of course, that the axis is 0, because if I said axis equals 1, it would be columns. So axis 0 tells Python to drop the rows with these index numbers, not the columns. This is what this looks like then. So note that I have dropped indices 0 and 1. So the first index that we're seeing here is 2. And I've also dropped index 5. So we're seeing index 4 followed by index 6 here. And that is the drop function applied to rows for row-based dimensionality reduction. This brings us to our second big topic in preprocessing, which is transforming data. Many of the algorithms that we're going to work with in this course require numeric data types. So we are going to learn now how to transform a string data type into a numeric data type for just that purpose. Our case study is going to be the race attribute from our adult small data frame, which you've built in one of the previous Your Turn assignments. In order to double check which data type an attribute is, we're going to use the dtypes function. Here's how this works. We're using our data frame dot, then the attribute name, dot dtypes. And for our adult small race attribute, Python tells me that the dtype is O. That's not the number 0. That's O. O stands for object, and that's basically a string value. So what we're going to do now is we're going to transform the race attribute to numeric values. It is a good practice to not directly transform an attribute in place, because we could theoretically mess up our data frame. So instead, we'll first add a new column, and then we're going to copy the contents of the race attribute into that column, and then in a second step, we will transform the values in that column and then double check those new values against the original race column. So here's how this works. I'm going to first create a race underscore num attribute, and I'm going to store adult small race in that race num attribute. And then I'm going to add this race num attribute as a new column to adult small. Here I'm going to call this also race underscore num. So I'm going to have adult small in brackets race num. That's the new column here. And that gets the contents of this race num here, which has the contents of adult small race. And then I'm going to check the contents of the new attribute. So let's do that right now. And we're seeing here this is adult small race num, race numeric, right? And now I can work with this and transform these values. Let's also double check the shape of the data set. Instead of the 12 attributes, we should have 10 rows and 13 columns. And we have 10 rows. Remember, the rows always come first. And 13 columns instead of the 12, which means, yes, we have added the race num column. Now that we have the race num column built, we are checking the data types of both of the attributes. So here again with adult small.dtypes, and we're going to check the data types of both columns. We're seeing they're both objects. Now that's going to change because we're going to transform race num into a numeric data type. So to transform an object value to a numeric value, we need to get the numbers from somewhere. And the easiest way to do that is to transform the object into a categorical attribute and then replace the values for the categorical levels with the index numbers for the category. And that gives us the numbers. And that's what we're going to do now. So the first step is to take the race num attribute and convert it to category. That's what we're doing with .as type category. And then we're going to replace the categories with their index numbers by saying, well, for the race num attribute, we're going to replace that with the category codes. And that allows us then to see the race num as an integer. Int 8 here is integer, so we know that it's a number, and race is still an object. So let's take a look at what the contents of these attributes look like. And we're seeing here white 1, black 0, white 1, white 1, white 1, and so on and so on. So we have converted black to 0 and white to 1. All right, so now that we've worked out the code on a smaller scale, we can do this on our entire data set on the big scale, right? So let's back up our data set again, our data frame. I'm going to call it adult 2. I don't think I've used 2 yet. So then we're going to do exactly the same thing. We're going to build our column here, and then we're going to convert our race num column on the big data set here to category, and then we're going to replace the category levels with the category index numbers here, the category indices, cat codes, and then we're going to check all the data types. Same thing that we did before, and as we can see here, we have an int 8 for race num and object for race. Okay, so that works, and now let's take a look at how pandas actually assign the numbers, because we saw here black was 0, white was 1 on our teeny tiny data frame. So now let's take a look at how that works on the big data frame, right? So we're going to call this, I'm going to call this race exploration because, you know, I can. And here I'm going to just stick race and race num into this data frame. And then I'm going to drop the duplicates so that all I see is just the unique values. And then I'm going to sort by the values in race num. And then I should be seeing the, there you go, here's my sort by race num, ascending, right? And here are the levels of race. So now it's your turn. How do you think were the numbers assigned to these specific levels of race? And that brings us to the end of our module on preprocessing, in which we've talked about subsetting and aggregating data. We've talked about slicing, subsetting, we've talked about aggregation and dimensionality reduction, and lastly, we've talked about how to transform data from string to numeric data type in order to prepare our data for easier processing by future algorithms. And now that you've made it to the end of this module, you have the tools to work with any and all future algorithms. Thank you so much, and I look forward to seeing you in the next video.